Okay, excuse me. Today's section is 2.3b, the remainder and factor theorems. Okay, this is an add-on to our polynomial long division and synthetic division. Okay, short and sweet. The remainder theorem tells you that if a polynomial f of x is divided by some factor x minus c, the remainder is f of c. Okay, so to get that in a little bit less abstract terms, okay, if we take this 4a, this example 4a, and I create that polynomial, 4x cubed plus 3x squared minus x plus, well, what a hoot. Smooth move. That's supposed to say an 8, not a 5, okay, because I'm taking this polynomial. So if I take that polynomial and divide it by this, okay, which is what we did right here, then they say that the remainder is equal to the value of the polynomial is equal to f of c, or f of 3 in this case. And I'm telling you, when people plug in, well, let me just finish this first, sorry. Okay, so again, you got a polynomial, you divide by something, the value of the polynomial is equal to the remainder. So my remainder 140 is what I'm going to get if I plug 3 in for x cubed, x squared, and x right there. But this is what I was trying to tell you before. A lot of people make more mistakes when they try to plug 3 in here and figure out what it is than they do with this process here. So it's another way of solving problems. And the first one that we're going to do is using that concept to do something called synthetic substitution. So when you see the word synthetic substitution, what they want you to do is synthetically divide to figure out what you get when you substitute. So here's the problem. The number of tickets sold during Northside High School football season can be modeled by T of x equals x cubed, excuse me, x cubed minus 12x squared plus 48x plus 74, where x is the number of games played. Use the remainder theorem to find the number of tickets sold during the 12th game of the Northside High School football season. Okay, so what am I going to do? I have that polynomial, so I'm going to go ahead and set up and write my coefficients. All right, those are my coefficients, 1, negative 12, 48, and 74. And I'm going to divide by 12. And so that is going to be the same as calculating f of 12, or the same thing as putting 12 in for x and plugging it in here. And I'm sure you can understand that's not fun to do if you don't have a calculator, okay? But let's go divide it. So the first thing I do is bring down my 1. 1 times 12 is 12. Negative 12 plus 12 is 0. 12 times 0 is 0. 48 plus 0 is 48. 12 times 48 is 576. And add those two together and you get 650. So what is the number of games? X is the number of games played. So find the number of tickets sold during the 12th game. And the answer is going to be 650 tickets. Okay? All right, last two problems, and this is dealing with the factor theorem. Okay? And I know that you know this, okay? If you have a problem, y'all, 15 divided by 3 is 5. We say that 5 or 3, whichever one you want to, is a factor of 15. Why is 3 a factor of 15? Because when I divide, the remainder is 0. So when we have that polynomial and we divide by a factor, if we have a remainder of 0, then we know that this is a factor of said polynomial. So this is how you use the factor theorem. Use the factor theorem to determine if the binomials given are factors of f of x. Use the binomials that are factors to write a factored form of f of x. So the first one I'm going to have, I'm going to use 3x cubed minus x squared minus 22x plus 24. Those are my coefficients. I'm going to use the factor given of x minus 2, and I'm trying to determine if it is a factor. So I'm going to plug in 2. set it up. I'm very interested in what's in this box. If it is a 0, the answer is yes, it is a factor. If it is not a 0, the answer is no. So start off by breaking down my 3. 2 times 3 is 6. -1 plus 6 is 5. 2 times 5 is 10. -22 plus 10 is -12. And 2 times -12 is -24. And add those and I get 0. So I say yes, we know that x minus 2 is a factor. Okay, so now when I want to do this one, y'all, okay, and I talked about this before, maybe I forgot, but this right here is what we call depressed polynomial. Okay, it reduced or depressed, but oftentimes it's called depressed also. But either way, this polynomial, if you ever get 0 here and you have to divide another factor, you can start all over again with these, but it's a heck of a lot easier if you use this one. You can only use this one if that's a 0. So I'm going to go plug -5 right here. And I'm going to bring down my 3. -5 times 3 is -15. -15 plus 5 is -10. 5 and -10 is 50. And -12 and 50 make 38. So the answer is no to the fact that x plus 5 is not a factor. Okay, so I answered it's not a factor. However, because I did have one that was a factor, then I have to write the factored form. Okay, so I'm starting off with x minus 2 because that's the original factor. And what do I have left? What's going to go in here is this guy right here. That was that reduced polynomial or depressed polynomial, which is going to be 3x squared plus 5x minus 12. And I have to factor that. Okay. Again, that's a whole nother video, so I'm going to just go quickly and tell you that you do have to try it. There are factors of 36 that subtract to give you 5. So it becomes 3x minus 4 and x plus 3. And that is how it factors. Okay, 6b, last problem. Y'all told you short and sweet. So my polynomial, 4x cubed minus 34x squared plus 54x plus 36. I don't need any 0 placeholders. All right, I'm going to set it up to go, and I'm going to start with x minus 6, which means I'm going to start with a 6 in this outside box. I'm going to carry down my 4. 6 times 4 is 24. -34 and 24 is -10. 6 times -10 is -60. 54 and -60 give me -6. And 6 times -6 is -36. Gives me a 0. So yes, x minus 6 is a factor. And so now I'm going to go try x minus 3. And so in my little box out here, I'm going to put a 3. And I'm going to carry down my 4. 3 times 4 is 12. -10 and 12 is 2. 3 times 2 is 6. And -6 and 6 is 0. So yes, I have another factor. So the nice thing about this, so from what I have, okay, I've got x minus 6 and x minus 3. And this gives me, I'm going to let y'all think about that for a second. It gives me 4x minus 2. But it's not factored completely, so I'm going to take a 2 out of there, and we always write the 2 in front. So I just moved it up front. But 4 divided by 2 is 2x, and 2 divided by 2 is 1. So that is the end, okay? On the notes, if you will look at it, this is a great summary of our synthetic and division remainders, okay? So short and sweet. Hope you enjoyed it. Please don't hesitate to email or contact us if you have any questions. Thank you for watching, and y'all have a great day.